So next protocol is time slotted channel hopping, or in short you can call it as 6TiSCH. Okay, time slotted channel hopping. Okay, this is a protocol for the access technology 80 IEEE 802.15.4e. Okay, and this is an add-on to the MAC layer. You can see media access control of this IEEE standard, that is 802.15.4. Okay, so with direct inheritance from other standards like wireless HART and ISA 100.11a. So along with this access technology, we use this protocol for the optimization of IP for IoT application. Okay, so devices which implements this particular protocol communicate by using time division multiple access. Okay, so devices which implements this particular protocol along with this access technology, that is 802.15.4e, it communicates with the help of time division multiple access schedule. Okay, and here bandwidth, with respect to bandwidth, that is an allocation of unit of bandwidth, or you can say time slot is scheduled between the neighbor nodes. So the available bandwidth will be assigned between the neighbor nodes in the network. Okay, and this assigning bandwidth or the schedule which is used here is allows the programming of predictable transmissions and enables deterministic and industrial type application. Because of this method or the schedule, this allows programming of predictable transmission and enables deterministic and industrial type application. Okay, so now to standardize this IPv6 over time slotted uh, channel hopping, time slotted channel hopping mode of this what uh, access technology is called as 6TI, time slotted channel hopping. So this time slotted channel hopping is called as 6 time slotted channel hopping because it is to standardize IPv6. Okay, so you can use IPv6 addressing along with this protocol. Okay, that's why the name given as TISCH. Okay, next, here the important element specified by this particular time slotted channel hopping working group is 6-stop. So that's why name is given as 6-stop here. Okay, and here you can see the sub layer that glues together MAC layer and 6-LoWPAN adaptation layer. Okay, so this sublayer, that means between the MAC layer and the adaptation layer, you can see this protocol where this particular protocol is used. So this sublayer provides commands to the upper network layer such as RPL, that is routing protocol. Okay, so in written, these commands enables functionalities including network layer routing decisions, configuration, and control procedures for times 6 time slotted channel hopping schedule management. As you can see here, this is the where this particular protocol or the layer is included between, you can see here, actually this IEEE 802.15.4e TSCH is included between the MAC layer and the IPv6 layer. Okay, so in along with IPv6 layer, you can we make use of 6-LoWPAN protocol. Okay, and also time slotted channel hopping along with this and what a layer is included between these two protocol, and that we call it as 6-stop. Okay, and schedules in this are broken down into cells. Okay, and a cell A cell is nothing but a single element in TSCH schedule that can be allocated for unidirectional or bidirectional communication between specific nodes. Okay, and the nodes only transmit when the schedule dictates that their cell is open for communication. Okay, so that is how it works. And this 6TiSCH architecture defines four scheduling management mechanism. One is static scheduling, next is neighbor to neighbor scheduling, and third one is remote monitoring and scheduling management, and last one is hop by hop scheduling. Okay, these are the four uh, schedule management mechanisms used for this, that is 6TiSCH architecture. Okay, and along with this, there are three forwarding models used under this architecture. The first one is track forwarding, next one is fragment forwarding, and the last one is IPv6 forwarding. Okay, three forwarding models are used. One is track forwarding, second one is fragment forwarding, and the last one is IPv6 forwarding. Okay, so next is RPL. As I said, it is routing protocol, okay, used for the low power and lossy network. I mean, the kindly mute Cypria.
Sorry, ma'am.
Okay,
Sorry.
it's okay. Okay, next one is RPL, where this RPL, as I said, routing protocol. It is a routing protocol used for the low power and lossy network. So nodes which runs with the help of low power, or you can say constrained nodes, for such type of networks, this RPL is used. And this is a new distance vector protocol. You might have studied distance vector protocol, routing protocol in CN lab, right? So this is a new distance vector routing protocol, which was named the IPv6 routing protocol for low power and lossy network. Okay, so in this network, each node acts as a router and becomes the part of a mesh network. So for this particular network, the topology followed is mesh network. Okay, and routing is performed in IP layer. Okay, and each node examines every received IPv6 packet and determines the next hop destination based on the information contained in the IPv6 header. Like it is usually done in the network, right? So the particular node will see the packet header to decide or to route the data to the next hop destination, right? So each node examines the received IP. See here, we are talking about IPv6, right? So it receives the IPv6 packet and determines what is the next hop destination to which the data need to be transmitted. Okay, and no information from the MAC layer header is needed to perform next hop determination. Okay, here IPv6 header packet is considered, not the MAC layer header part, to determine the next hop destination. Okay, and RPL, routing protocol for lossy network, right? So this based on a concept called DAG, that is direct acyclic graph. So this DAG, since it is acyclic, there will not be any cycle that exists in the graph. Okay, so that means what? From any vertex or point in the graph, we cannot follow an edge or a line back to this same point. That means there should not be any cycle exist in the graph. And do remember, it is a directed graph. All the edges are arranged in paths oriented towards and terminating at one or more root nodes. Okay, so this RPL uses two modes, that is storing mode and non-storing mode. So these are the two modes used under what RPL. Here Storing mode means all nodes containing the full routing table of RPL domain. That means whatever the nodes that are present in the network will store or will contain full routing table. That means for the whole network, from this particular node to what is the next available node, or what are the other available nodes to which this particular node can send the message or the data. That complete routing information is stored in the nodes, in all the nodes in the network. That is, we call it as storing mode. And next one is non-storing mode, where only the border routers of RPL domain contains the full routing table. So here the nodes which are very close to the next router, that will be having the full routing table with it. Not all the nodes will have or will maintain full routing table. Okay, so this is an example where you can see multiple nodes are there. Okay, and here you can see no cycle exists. This is a directed or cyclic graph. You can see no cycles are exist. So this is how, or you can see this is an example for DAG. And one more thing is that the basic RPL process involves building a destination oriented directed or cyclic graph. That is, we call it as DODAG. Okay, so this you can see, actually this image represents DODAG and this is DAG. Okay, where no cycles are present. Here also no, cycles are not present, but there is a difference. That is, DODAG DODAG is a DAG routed to one destination. You can see all the nodes that are present in the network are routed to one destination. Okay, so in RPL, this destination occurs at the border router known as DODAG route. So this is called as route for this network. Okay, and all you can see all the nodes are routed to one destination, that is route here. Okay, and then this DAG has you can see here a DAG has multiple routes, whereas DODAG has just one route. Okay, so in DODAG each node maintains up to 3 parents that provide a path to the route. Okay, that provide a path to the route. Next, one of these parents is the preferred parent, which means it is preferred next hop for upward routes towards the route. I mean, this says how the data will be forwarded to the next node that is present in the network. Okay, so the routing graph created by the set of DODAG parents across all nodes defines the full setup of upward routes. Okay, so that is the explanation for how actually this DODAG works. Okay, RPL protocol implementation should ensure that routes are loop free by disallowing nodes from selected DODAG parents that are positioned further away from the border router. Okay, so that is how the RPL works with respect to DAG. Okay, this RPL has messages, that is DO and DAO. Okay, see this DO is DAG information object message. Okay, DIO stands for DAG information object message, and this this is DAO, that is destination advertisement object message. Okay, this includes two types of message, that is DIO and DAO, which run on top of the IPv6. Okay, these message exchange and advertise downstream and upstream routing information between a border router and the nodes under it. Okay, with the help of these messages, the message exchange will happen, which advertise downstream and upstream routing information between a border router and a nodes under it. Okay, and here you can see the message flow that is DAO and DIO message flow, downstream and upstream. Okay, here you can see these are the ranks assigned for the nodes. This is overview of RPL. You can see this is IP WAN, whatever given here. This acts as root, DODAG. Okay, you can see all are aiming at one root, that is IP WAN. Okay, and this whole thing, this whole thing we call it as RPL instance. Okay, and here you can see messages can go upward and the downward, that is DAO and DIO messages travel both up and downwards, the DODAG depending on the message type. That's why here you can see bidirectional arrows are used. Okay, that is RPL overview. Here you can see the ranks are assigned 1, 2, 3, 4, right? So this rank is a rough approximation of how close these nodes are to the root. Okay, so and this also helps avoid routing loops and the count to infinity problem. See, ranking the nodes will say how close the particular node to the root, and it also helps few problems like routing loops or count to infinity problem. Okay, so that is all about RPL. That is about a rank, it is given here. Okay, and some of the RPL routing metrics and the constraints which are defined in RFC 6551 includes, I mean, these are the few metrics followed for RPL. Okay, so that is expected transmission count, hop count, latency, link quality level, link color, node state and attribute, node energy, and throughput. So these are the RPL routing metrics and constraints that is followed for this RPL, routing protocol for lossy networks. Okay, so that concludes the first chapter under module 3. Okay, so in this chapter, what and all we discussed, I'll just summarize what we discussed under this chapter. Okay, so this are all about IP as the IoT network layer. Okay, and in this we discussed business case for IP, the need for optimization, optimizing IP for IoT, and the last one, profiles and compliances. That is a few data is given. I want you to go through it. Okay, and what else we discussed? We discussed adoption or adaptation of the internet protocol, right? And then we discussed about constrained nodes, constrained networks, IP versions, right? And also under optimizing IP for IoT, we discussed adaptation layer is included between the data link layer and network layer. And also we discussed 6 low pan header stacks, right? And next we discussed uh, this time slotted channel hopping, that is 6 top, that's why it is called as 6 time slotted channel hopping. And then we discussed RPL and how actually this RPL works, right? And what are the, how RPL network is represented, what is DAG, what is DODAG, and what are the metrics that is considered for metrics as well as constraints considered for this RPL router, RPL protocol, right? And and there is few thing, that is how authentication and encryption are provided for the constraint nodes. See, do remember, constraint nodes are what, which can't, which don't have uh, enough power to perform the data access. That means whatever the resources are provided for this node are very limited. Okay, so here uh, the networks, authentication and encryption are also performed. Okay, and that means security can be provided. uh, by following authentication and authorization for constrained environments. Okay, so and also in constrained environment, constrained environments are secured by following protocols like DTLS, COAP, okay, which are also used to control resources on a device. Okay, so that is what I just wanted to tell you about IP as the IoT